All right, so here we go. Let's have a quick look at this. If you want to keep working, that's fine. I'll leave a light on for you. Rest of you, let's have a look up here. Oh yeah, for the, which one is this for? It's for the, oh, it's your username and then username, yeah. Okay. All right, here we go. So what about this? Least common denominator.
My car is trash.
Okay, what about that? Finding least common denominator, what do we do? Factor. Yeah, and we just care about the denominators. We don't care about, right, in this question, all we're trying to do is deal with the denominators. So we've got this guy. What can we do with that? We take out what? 4. And then that would leave us with, see if we can do the whole thing. If we take out a 4, we're going to get a 1, a 5, and a negative 6. So that's going to be, what's that going to be? Plus, x plus 6, x minus 1. Does that make sense?
Yes, sir.
Right? Everybody good with that? Okay, this guy here, we can take out an 8, it looks like. And then we're left with x squared minus 48. Is that right? No. 8 goes into 3. So 36 it must be, right?
Yeah.
Okay, so that factors into 8 times x minus 6, x plus 6. And so then what's our LCD? What's the number part?
X minus 6, X plus 6.
Okay, but what's the number part? We gotta find the least common multiple of 4 and 8.
Oh, 8.
8. There it is. Okay? Okay, let's see here. Okay, yay or nay?
Factors.
Okay? All right, so on this one, our thinking is we're just gonna factor top and bottom, right? But there's really nothing to factor on the top. So we're gonna get, let's see, 11 over, I can take a 2 out. And then my coefficients are 1, negative 5, and 6. So that's gonna be negative 2, negative 3. Everybody buy that? Is that right? Yeah. Multiplies, yeah, that's good. Okay? Plus, over here, we've got 7 over, we take a 3 out. Then our coefficients are 1, negative 6. I'll just do that. So we get 3 times x squared minus 8x plus 12. So what's that? Negative 2, negative 6. Okay, so then when we're adding stuff up, we just want a common denominator, right? So our common denominator is going to be, we can write it down if we want to. Probably a good idea. What's it going to be? What's the least common multiple of the numbers?
6.
6. Okay, and then we're gonna need to have all those factors that are included. So there's a double factor, a shared factor. Here's our x minus 3. Here's our x minus 6, right?
Wait, so between the 2 and the 3, you gotta find the least common multiple of that?
Yeah.
Okay, so
Yeah.
like, if one of them is a multiple of the other one, like say you had 2 and 8, would it just be 8?
You mean like in that example right there where it's just 8?
Oh, okay.
Yeah.
So if one's a factor of the other, you just take it out?
Yeah. Yeah, remember, all least common multiple means is the smallest number they both divide into, right? Okay, so then, on this one, remember what you always wanna do with these, just like with numbers, you wanna decide what do you have to multiply the bottom by to get the common denominator, and then you do the same to the top, right? So what would we have to multiply, let's get rid of this. The first fraction, what do I have to multiply it by to get my LCD? Yeah, I'm gonna have to have a 3 to get a 6, right? And then I'm missing the factor x minus 6. So I'm gonna do the same thing, top and bottom. And of course, remember why we do that, because we're multiplying by 1, so we're not changing it, right? How about over here?
2 times
X minus 3, you said? Okay, good, so then, what's that give us? Well, we know that we're gonna break this into 2 parts then. You guys don't have to skip a step. You're advanced algebra students. You can just write this out with the common denominator now on the bottom. You don't have to expand it out. It doesn't tell you to. Just leave it factored, that's fine. Yeah, it's actually better, because what if the top ends up having a common factor that you can cancel? 6, x minus 2, x minus 3, x minus 6. And then what do we get on the top? Okay, so let's look at the top. The top is just like always, it's just gonna be whatever you get when you, in this case, add the numerators, because it's a sum. It's a difference, we'd subtract them, right? So let's just simplify this then. We get 11 times 3 times x minus 6. So that's 33x minus, what's that gonna be, 198? Right? Plus, what about over here? 7 times 2 is 14 times the quantity x minus 3, 14x minus 42. And so then our answer would just be whatever we get on top simplified. So 33x plus 14x, what is that, it's 47x. Minus 198, minus 42, negative 240. Okay, that obviously doesn't factor. We can't take anything out, right? So we're done. And the bottom is just that stuff, right? Okay, those are the hardest problems. I think the adding and subtracting ones are probably the hardest ones on the assignment, okay? What if this were the problem that asked you to find excluded values of x? What would they be?
2, 3.
Yeah, I'd have to have 2, 3, and what's the other one? 6. Yeah. And you can look right up here and see whatever the factors are of the least common denominator, right? Okay, because those are on the bottom. Questions?
Can we do another one?
Yeah, absolutely. Okay, you want to do like a division one maybe? What do you think?
Where it equals something.
Okay, let's do that first, and then we'll do a division one. So I'm gonna scoot up to like up there. See what we got. I think it's these last 2 or 3 that are.
Yeah, like that.
Yeah, there we go. Okay, yeah, what about these? Okay, so we want to do 2 things. Find the solutions, find excluded x values. So on the, as I'm writing the questions for the final, I'm only gonna make these have one part, but what it's gonna say is just find all valid solutions, right? So you can't include any extraneous solutions. Okay. So let's just pretend it's like that, how about? All right, so, what is our least common denominator here?
This was, that's not there.
Okay, so, right, so this is just the product of x plus 3 times x plus 6, isn't it? Right? So the least common denominator is just the product of x plus 3 times x plus 6. Everybody buy that? Okay, so let me write that down. Which is equal to x squared plus 9x plus 18, right? So what am I gonna do then? When we're solving these, remember what our trick is. We're just gonna clear the fractions, right? Just like we normally would. We're gonna clear the fractions, multiply everything through by the least common denominator to get rid of all the fractions and write it as an equation, okay? So we end up with then, but before we do that, we have to take into account what are gonna be our excluded values. Okay, so x cannot equal -3 and x cannot equal -6. Why do we have to do that? Because when we clear the fractions, this is gonna look like a regular equation with no exclusions, right? So just in the event that we get answers that are actually excluded values, we can't include those. You gotta write those down, right? Before you actually clear the fractions. So now if we multiply everything through, we're just gonna distribute the LCD to both sides. Okay, what's that look like if we do that? If I distribute the least common denominator to both sides, what do we get? Well, if I multiply this fraction by it, it just goes away, doesn't it? Everybody agree? Do you want me to write that step out? Maybe I will. So we've got -6 over something like that, right? So we're gonna multiply, distribute through both sides. We're gonna multiply by x plus 3 times x plus 6. Okay, so what's that give us? It allows us to actually skip this step, doesn't it? Because think about it this way. If we're clearing the fractions, only the part that's not included is not gonna cancel, right? So in this case, both of those cancel and I just get a -6. Probably could have just skipped right to that result. Plus, what about here? Well, I have an x plus 3 on the bottom, so that's gonna cancel. What am I left with in my least common denominator? X plus 6. Right? And then over here I have an x plus 6, that's going to cancel, leaving me with an x plus 3 times whatever was there in the numerator. So there's the equation I'm going to solve, right? And at that point it gets pretty simple, then it's just solving a quadratic equation. So if we expand this out, what do we get? -6 plus 3x plus 18 equals x squared plus 7x plus 12. What do I gotta do to solve this? What do I always do with quadratic, in any equation? Set equal to 0, put it in standard form. So we'll move everything over this way and get x squared plus 4x, add 6, so that's plus 18. That's kind of weird, huh? Did I do that right? X plus 3. Huh, I guess. So does that have any real solutions? No real solutions, right? Everybody agree?
Shouldn't it be
How do we,
plus 4x?
say it again?
Shouldn't it just be x squared plus 4x?
Oh, there's the problem. Yeah, I got it. I forgot this 18, didn't I? Yeah, there we go. Good. There's the problem. Okay. I forgot that 18. Negative 6 plus 18 is 12. 12 minus 12 is 0. Good. Okay, so now if I factor this, I can take out an x, right? So what are my solutions? What are my zeros? X equals 0, 4, negative 4. Are those on my excluded list? No, they're not. So those are good solutions. Okay, on the test though, on the final, you only get one retake on the final. Yeah, that's kind of the math policy. So you gotta check your answers. How would you check this?
Plug them back in.
Plug them in. Plug them in. How would we? Let's talk about this a little bit. How would we check that one? What's your strategy? It's easy to do. Kirk, remember what you do to check those? Good trick, remember? Ruby? All you gotta do, if I'm finding a sum, that's simplifying, right? All I'm doing is writing it in a simpler form. The value of the expression should stay the same though, right? For any value of x. Agreed? So all I've gotta do is pick a random value of x, plug it into the original, get an answer, plug it into my simplified version, and if I get the same result back, then that's a pretty good check that I did it correctly. If I get a different result, then that means that this is it's not algebraically equivalent to what I started with, and I made an algebra mistake, and I start over, but I don't submit it, right? Does that make sense? It'll be ready tomorrow for sure. Yeah, I'll put the practice test up today. I've got a few more questions to do, and it'll be ready tomorrow. I will give you, first time through, I tell you what, I will give you, because it's, in case there's any bugs, I'll give you one free. So effectively, you actually do get 3, just because it's the first time we're using this one. I'll give you a freebie, like tomorrow or Thursday, whatever, that's fine, right? So I'll delete 1 for you.
So regardless of whether or not we finish the test, we should at least take the revision on it.
Or I'm gonna be gone Thursday, so it's, Thursday might not be a bad day to do that. Maybe I'll set Thursday as the day I'll give you a freebie. Okay, let's keep going.
How many questions so far?
I think it's gonna be 28, but they're pretty, I mean, just to give you an idea, I actually had to go through, in order to make this kind of sync up, I had to rewrite some questions to make them easier. I didn't have any equivalent, So you guys do not need to worry, you're gonna be fine. But I think it's a good thing to do. I'm glad, it forces you to go back. We'll review this tomorrow. I'll put up a practice one, and you'll see that it covers, really it's a good final. It covers 7 different main topics that kind of cover more of the analytical parts of Algebra 2, like solving equations, factoring. There's nothing really big and onerous on it. I mean, you don't have to do any great big polynomial equations or anything. You just have to be able to do a little bit of this stuff we're doing. Be able to use properties of exponents. I mean, there's just 7 little topics that we've done a ton with. It won't be hard, but it forces you to go back and make sure you kind of rethink it a little bit, so you don't forget it. All right, but not anything to worry about.
Where do I sign up for college algebra?
I don't know. Talk to Mrs. Jones, but I don't think you should do that. Okay, this one, we already did this one, didn't we? We did this one in class. We did.
I don't remember that.
Yeah, we did.
Yeah, we did.
We did. We did. We did. Come on. Okay, what about, I mean, do you wanna do another one of these or not? You guys, I don't care. You wanna do a quotient, do a divide? You wanna do one of these, or you just, you tell me when to stop. I'll do math forever if you don't stop me.
I know we already know this, right?
Do that one again.
Story problem? Okay. Oops. Okay, and there could be others that are real, same concept, but what are they looking at here? If somebody's made 15 of 22 free throws, that's a percentage of about 68%. How do you get that? I mean, what is that? How do you find out what your free throw percentage? 15 divided by 22 written as a percent, right? So if we want to know how many must he make in a row in order to raise his percentage to 94%, how are we going to set that up then? Right? We need 94% to be his makes over his total attempts, right? What's the variable here? What are they asking for?
It's amount of shots.
How many consecutive shots he needs to make, so call that X, right? So we're gonna go ahead and let X equals consecutive free throws, right? And so then what has to equal 0.94? Okay, so whatever he starts with, the number of makes he had plus X divided by equals 94%, right? Okay, does that make sense? And then I'm just solving that, right? I could write this as 94 over 100 too, make it a fraction if I want to, might as well. And then let's talk about this for and I can reduce that fraction if I want to. But when I get a simple, that's called a proportion, right? If I just have a fraction equal to a fraction like that, how do we solve proportions? What's an easy way to do it? Cross multiply. Yeah, right? I mean, that is what we do, isn't it? Our common denominator would just be, and in this case, it wouldn't even be our common denominator. I mean, we could actually reduce this. Why don't we do that? That becomes what? 47 over 50, is that right? So if I cross multiply 50 times 15 plus X equals 47 times 22 plus X, right? Just solve for X. What if I end up getting X equals like 17.3? 18 is the answer then, isn't it? 17 is not enough. And you can't shoot a partial free throw, right? Okay. Anything else we want to go through? Division problem?
Yes, sir.
Okay. I think those were back here. Let's try these. Yeah, something like that. Okay. This is just asking for the domain, but why don't we just do this problem? On the test, I'm not going to ask you for the domains. I'm just going to ask you for a simplified answer. Okay, so if we are keeping track of domain though, let's think about that. Let's just keep track here. What do I have to do to this before I do anything? Gotta factor it, right? We gotta factor it so we can cancel common factors eventually. So what am I gonna get here? What numbers multiply to 72 and add to negative 17?
Minus 8 x minus 9.
Divided by 5x divided by, and I'm just gonna write it this way this time, we haven't done this yet. I'm gonna write it as a quotient of fractions. So on the bottom, we'd end up with, what do we get here? This will be our green fraction. Factors into what, x minus 9, x minus 2. Divided by 4x times x minus 4. Okay, so at this point, what's our domain? What numbers do we have to exclude? Yeah, because I've got to look at the denominators of both expressions, right? Can't divide by 0. So x cannot equal 0 because of that guy and that guy, and x cannot equal 4 because of that guy, right? So now what's next? What do you do when you divide? Flip and multiply, good. So we end up with then the yellow fraction, or the yellow expression, times the reciprocal of the bottom. So 4x times x minus 4 over something like that, right? Okay, and because I'm multiplying, I multiply straight across, so everything in the top is a factor of the numerator, everything in the bottom is a factor of the denominator. And so here's where we can start to pare this down. Do we have any additional values we have to exclude from our domain? 2 and 9, it looks like, 2, right? Okay, and what can we cancel? We can cancel 9s. Is that it? No, x's. I think that's it, huh? Right, so our answer then is just going to equal 4 times the quantity x minus 8 times the quantity x minus 4 over 5 times the quantity x minus 2. That's it, x minus 2, right?
Mr. Roy?
Yep.
I was done writing down stuff on the paper. I don't know how you got from the two fractions like on top of each other to over to the right.
To the right?
Yeah.
Okay, so what does this mean? This just means yellow fraction divided by green fraction.
Yeah, but then
So-
the fractions changed. I don't know why that.
Did they change?
Does it look like they flipped?
Oh, they flipped.
Oh, okay.
Because when you dividing by the green fraction is equivalent to multiplying by its reciprocal.
Yeah, okay.
Okay, does that make sense?
Nice.
And so division, multiplication is way easier than addition or subtraction. I mean, the hardest one we did was probably that first problem, getting the common denominator. Those are the tougher ones. These are simple because you multiply straight across, right? Division is really almost no harder than multiplication because all you do is flip and then multiply, right?
Yes.
The only tricky part of the whole thing, I think, with division is just that you have to keep track of all of the excluded values, including the step before you flip, right? That's it, though. Okay? Make sense? Okay? More, or you want to keep working? I gotta take a roll anyway, so I guess we have 2 minutes. Yeah.